If we are talking about application of the synchronous machine, uh, earlier I discussed about the around 90 to 95% usage of the synchronous machine as a synchronous generator, remaining 5 to 10% usage of the synchronous machine as a synchronous motor and synchronous generator. First of all, I will clear the what is mean by the synchronous generator and what is mean by the synchronous motor and what is mean by the synchronous condenser. With the if we are talking about synchronous generator, with the help of prime mover, we are generating power, AC power, alternating power through the synchronous generator. Synchronous generator are two types. One is the salient pole synchronous generator, other is the cylindrical type synchronous generator. Salient means its rotor are in a construct. Its rotor construction is salient type. That means projected type. And this type of synchronous generator are widely used in hydropower plant. And other type of the synchronous generator is cylindrical type synchronous generator. Cylindrical type synchronous generator having features of uniform air gap, small diameter, and large axial length. If we are talking about salient pole synchronous machine, it has larger diameter, smaller axial length, and it operated low frequency around 15 hertz 1500 rpm. If we are talking about cylindrical synchronous generator, it operated at a higher speed around 3000 rpm. This is the basic difference between salient pole synchronous generator and cylindrical pole synchronous generator. Now, if we are talking about motor, motor are same construction and same type, salient pole synchronous motor and cylindrical type synchronous motor. And after that, I will discuss about the synchronous condenser. Synchronous condenser is the very important device which is widely used to reactive power compensation. It is the dynamic device which work as a reactor during the no load and under excitation condition. Synchronous motor is working as a inductive load. If we are overexcited the field winding and no load condition, then it's working as a capacitor, which is used in a transmission line for reactive power compensation. That's why I'm telling you around 5 to 10% usage of the as a motor as a synchronous condenser. Synchronous condenser is the very important device for the power factor improvement, reactive power compensation, etc. So these are the basic introduction of the synchronous machine. And after that, this is the basic construction of the synchronous machine. दिखाई दे रहा है सारे लोगों को? पहली आवाज सुनाई दे रहा है? हाँ सर दिख रहा है। अब देखिए बेटा यहाँ पे जो है द आउटर पार्ट इज नोन एज फ्रेम. फ्रेम इज मेड ऑफ कास्ट आयरन एंड इनर this black color circular cylindrical are known as rotor. ठीक है, इसको हम रोटर बोलते हैं. और ये जो है फ्रेम है, फ्रेम के ऊपर जो है स्लॉट्स बने होते हैं. फ्रेम के ऊपर जो है स्लॉट्स बने होते हैं. स्लॉट्स के अंदर कंडक्टर होते हैं. कंडक्टर के ऊपर जो है कोर फॉर्म होता है. स्लॉट्स के ऊपर ही कोर बने होते हैं और स्लॉट्स के अंदर जो है 3 फेज वाइंडिंग जो है हम स्टेटर के अंदर करते हैं, जबकि रोटर के अंदर जो है हम फील्ड वाइंडिंग को करते हैं. अब ऐसा क्यों करते हैं? क्योंकि हमको जो है लार्ज स्केल पे पावर का जनरेशन करना है, तो लार्ज स्केल पे पावर का जनरेशन करेंगे, लेकिन इट हैज आल्सो लिमिटेशंस. वी कांट जनरेट पावर बियॉन्ड 11 to 15 kV because the problem of the insulation failure. ठीक है ना? If we are talking about DC generator, तो DC generator having limitations because uh, spark in brushes, and that's why if we are generating power at a large scale, then we must did the armature winding on a stator and field winding on a rotor. But if we are talking about a DC machine, so armature is on a rotor because for a commutation process for the commutator, and that create a problem of limit. We can generate voltage at limited value. Beyond, we can't generate the DC voltage due to the sparking and commutation problem. ठीक है? So that's why we are did the field winding on a rotor side and armature winding on a stator side. Armature winding having three-phase winding which handle large scale power generated during the generating operation. ठीक है? अब ये यहाँ पे सारी चीजें दिख रही हैं, किसी को कोई डाउट है तो बताइए.
नो सर.
No, sir.
ठीक है, अभी तक जो भी मैंने बताया है, आर यू गेटिंग प्रॉपरली?
यस सर.
Then the synchronous generator or alternator are used to convert mechanical power delivered from the steam, gas, hydraulic turbine to electric power. As we know that alternator, synchronous generator or alternator or synchronous generator are same thing. There is no need to confuse them. Are used to convert. It is used to convert mechanical energy driven from steam, gas, hydraulic turbine to electric power. This is the basic concept of the synchronous generator. And synchronous generator are the primary source of the electrical energy we consume today. This is the primary source of the generator, मतलब primary source of the electrical energy generation which we consume today. जो हम आज जो पावर को कंज्यूम कर रहे हैं, that is the generated by the synchronous generator all over the world. It is the widely used in all over world. Large AC power network relay almost exclusively on a synchronous generator. Synchronous motor are built in a large unit compared to the induction motor. Induction motor are cheaper for a small rating and used for a constant speed industrial drive. If we are talking about, that's why I'm telling before that the usage of the synchronous motor are limited around 5 to 10%. ठीक है ना? हेलो, ठीक है, 5 to 10%. ठीक है. After that I will discuss about basic construction of the synchronous machine. Basic part of the synchronous generator. The rotor is DC excited winding. That means we are talking about rotor having field winding. ठीक है ना? Stator having three-phase winding in which the AC EMF is generated. The manner in which the active part of the synchronous machine are could determine its overall physical size and structure. Are you watching the construction of the synchronous generator? Hello. This is the rotor, and this is the part of the rotor. Having following part. This is the shaft. This is the outer cage. This is the field magnet, and this is the wire. This is the brushes. Brushes is like that, and brushes spring is here, are pushing them to always maintain in contact with this slip ring, and ball or plane bearing. This is the bearing, bearing is used to support soft to frame of the machine. Commutator is used to DC machine, not used in AC machine. ठीक है ना? अब यहाँ तक समझ में आया? हेलो,
Yes, sir.
ठीक है? Any problem? Any doubt? हेलो, ठीक है. I will give you some time for a short note. First of all, I discuss all the slide which I represented here, and after that I will move to next slide. This is the type of the synchronous machine. As earlier I discussed about that. The salient pole synchronous machine, cylindrical, yeah, round rotor synchronous machine. This is the round rotor, yeah, cylindrical type synchronous machine. This is the cylindrical structure. Are you getting my point? This is the slots. In a slots, there will be the field winding is made. Here the winding is made, and rotor is look like that. ठीक है ना? Are you watching?
Output of the control system is react to the summit point. The output of the control system. The output of the control system is react to the summit point.
हेलो,
Yes, sir.
दिख रहा है सब आप लोगों को?
हाँ जी.
ठीक है. After that, I will discuss about the salient pole synchronous generator. The most hydraulic turbine have to run a low speed between 50 and 3 RPM. As earlier discussion, I told you that for a low speed applications, we are using salient pole synchronous machine, and also I discuss about the application of synchronous generator in a hydropower plant. In a hydropower plant, we are using salient pole synchronous generator due to the low speed. And if we are talking about the number of pole are increases to 2 to 12. But if we are talking about number of pole in cylindrical rotor having number of poles 2 or 4. Maximum cylindrical rotor having 4 pole. But if we are talking about salient pole synchronous generator, then it has vary 2 to 12. ठीक है ना? This is the salient type structure. This is the coil, rotor coil. This is, ठीक है ना? दिख रहा है सारे लोगों को? हेलो.
Yes, sir.
हाँ सर.
हाँ सर, दिख रहा है.
And this is the generator, and this is the stator, and this is the rotor. ठीक है? This is the turbine. This is the diagram of the hydropower plant. If we are talking about hydropower plant, the hydropower plant is having main two parts, mechanical and electrical. Mechanical part having turbine having different type of turbine, propeller, Francis, and impulsive type turbine are used for the used in a hydropower plant. And now generator are used in a salient pole synchronous generator. As I earlier told about the salient feature of the salient pole synchronous generator is it has larger diameter and lower axial length. It operated low speed around 50 RPM to 3000. Yeah, maximum it operated at a 1500 RPM. ठीक है? दिख रहा है आप लोगों को?
Yes, sir.
ठीक है. Now we are talking about salient pole synchronous generator. This is the turbine driven rotor. Rotor is like that, and this is the slip ring. Slip ring. Why we are using slip ring? The brushes are sliding on a slip. ठीक है? And we are DC supply to the rotor circuit through the slip ring and brushes. ठीक है? Turbine on a driven rotor, and this is the systematic diagram, and this is cross section area, and this is cylindrical type, and this is the salient pole type rotor. These two. If we are talking about cross section area, this is in a case of cylindrical type. This type of cross section area look like. And if we are talking about salient pole synchronous rotor, synchronous generator rotor, this will look like that. ठीक है? यहाँ तक समझ में आया? हेलो?
हाँ सर आ गया।
यस सर।
रिकॉर्डिंग हो रही है ना?
हाँ हाँ सर, हो रहा है।
ठीक है। अब इसके बाद now we will move to next step, cylindrical rotor synchronous generator. If we are talking about steam power plant, then the actual diameter and length of the rotor is around, if we are talking about diameter is around 1 meter and length is around 10 meter. We supposed to how the big size of the rotor of the alternator which produces larger power, and this is if we are talking about speed of the cylindrical rotor synchronous generator. Earlier I told you that for a two-pole machine having operated at 3600 rpm and four-pole machine is operated at 18 rpm, and direct conducting cooling. Actually, if we are talking about cooling of the synchronous machine, our synchronous generator are operated around जो है 24 hour, ठीक है ना, in monthly, yearly, maybe larger time. If current is flowing through the conductor, then if current is flowing through the conductor having its own resistance. Due to the resistance, the I square R losses is made, and that's why the heat is generated in a armature winding and any winding where current is flowing, and that required to need the cooling system. Cooling system are used to cool the winding from heating effect. That's why if we are talking about the cooling of the stator and cooling of the rotor, the stator cooling is water cooling and rotor cooling is the hydrogen cooling are used for the cooling purpose. The rating of the machine is up to 2000 MVA, megavolt ampere is the larger value, and this is the basic construction diagram of the synchronous generator. This is the bearing surface, and this is the north pole, and this is the bearing surface, and drive noise and magnetic pole faces is here. This is the south north, north south, etc. Okay, are you getting my point? Hello. हेलो।
हाँ सर।
पहली आवाज सुनाई दे रही है?
हाँ सर सुनाई दे रही है।
ठीक है।
Yes, sir.
And after that we are talking about cylindrical rotor synchronous generator. This is the here we are talking about cylindrical rotor synchronous generator. This is the rotor slots, and winding are made to the rotor slots, and this is the actual view of the stator, and this is the actual view of the rotor having field winding and stator having armature winding having three-phase winding, as discussed in a three-phase induction machine. RYB is the phase of the stator. Same phase are synchronous generator. This is the rotor construction. Cylindrical rotor is here. This is the slots. In slots, we are made a field winding, and externally we are supply DC supply to the rotor winding, and with the help of prime mover, we are apply a kinetic energy in the form of rotation, and which induces the EMF in armature winding. I discussed in a previous mini lecture how the EMF is induced. If magnetic field and coil are linked to each other, and magnetic field is changing with respect to time, then coil induces the EMF. In this process, there will be three-phase AC is generated in a stator winding of the synchronous machine. ठीक है? Are you getting? Hello.
Yes,
Yes,
sir.
sir.
After that, I will discuss about the basic working principle of the synchronous generator. I will start step by step for a discussion. The rotor of generator is driven by the prime mover, as we know, and I told you that in a synchronous generator, if we are talking about synchronous generator, there will be the prime mover as a mechanical part, which supply the kinetic energy to the rotor, and rotor is rotating in a armature coil, which rotor is supplied by the DC. Rotor is connected to the DC supply, which create which create or generate permanent magnet. If magnet is generated as south and magnet is generated as north, this is the fixed. One is the north and the other is the south. And with the help of prime mover, we are rotating, yeah, we are providing kinetic energy. Then the flux is linking to the coil. It changes with respect to the time. If flux is changes with respect to time, then the concept of the Faraday law of electromagnetic induction, Lenz law, is comes under the armature winding, which produces the EMF in a coil. Coil having three-phase winding, R by B, and EMF is generated accordingly the three-phase winding. That's why R, Y, or B phase are generated in a armature winding, which is step up by the step step up transformer and transmitted to the transmission line and finally supplied to the distribution end. This is the basic concept of the basic working principle of the synchronous generator. ठीक है? And the next concept I will discuss about the now how the EMF is generated and what is the frequency. The electrical frequency produced is locked or synchronous to the mechanical speed of the rotor of the synchronous generator. If we are talking about what happen in synchronous generator, the armature winding is connected to the load during starting of the prime mover. The rotor is rotating. The air gap of cylindrical type synchronous generator is uniform, and the permanent magnet, which is created through the DC supply applied to the rotor winding, which generate constant magnet north pole and south pole, and which is rotating in a armature winding and cut to the armature coil, and frequency generated through the formula F is equal to Pn divided by 120, where P is the number of poles and N is the speed of the rotor, where electrical frequency in hertz, number of poles, speed of the rotor in RPM. ठीक है? The frequencies depend on a number of pole and speed of the rotor in a RPM. This is the 0, 180, 136, and this is 0, 180, 36. This is the 8-pole low speed machine, and this is the 2-pole low speed machine. Is the generated EMF is like that. ठीक है? समझ में आ रहा है?
Yes, sir.
थोड़ा बहुत कुछ समझ में आ रहा है या फिर बताएं हम उधर ठेठ में? हेलो, अगर समझ में नहीं आ रहा है तो फिर बताइए आप लोग, और दूसरे तरीके से बताया जाए इसको. चलिए ठीक है, पहले शॉर्ट नोट तैयार करिए, फिर इसके बाद हम करते हैं. अब देखिए थ्री फेज जो है कैसे जनरेट होता है। अब ये सारी चीजें थ्री फेज कैसे जनरेट होता है वो सारी चीजें जो है मैं आपको एक नेक्स्ट लेक्चर में जो है अब उसमें व्हाइट बोर्ड यूज करूंगा, उसमें मैं बताऊंगा किस तरह से जो है हमारा फेज जनरेट होता है। अब यहाँ पे जो है जनरेटेड वोल्टेज ऑफ सिंक्रोनस जनरेटर इज गिवन बाई ई इज इक्वल टू के सी फाई एफ ई, वेयर फाई इज द फ्लक्स इन आर्मेचर फंक्शन ऑफ आई एफ, Fe is the electrical frequency, Kc is the synchronous machine constant. This is the phase 1, phase 2 and phase 3. We did the three phase winding, each phase are displaced by 120 degree, and that's why the generated EMF is also displaced by 120 degree. This is the 120 degree phase displacement. ठीक है? The phase displacement between phase 1 and phase 2 is 120, phase 2 and phase 3 is 120, and phase 3 and phase 1 is 120. Every phase has a phase displacement 120. ठीक है?
ठीक है
Yes,
सर।
sir.
This is the per phase equivalent circuit. If we are discussing about the equivalent circuit, we are taking single line diagram only and multiply by 3, then we can find the three phase characteristics through the single line diagram. ठीक है ना? This is the equivalent circuit of the synchronous machine. This is the generated EMF, and this is the reactance, and this is the resistance of the armature winding. Because if we are talking about the conductor armature winding having conductor having its particular resistance and reactance. If current is flowing through the conductor, then the reactance inductance are produces which form the inductance value xc. This is the armature generated EMF, and this is the terminal voltage. ठीक है? And if we are looking practical view of the synchronous motor, this look like that. A synchronous motor is the same physical machine as a generator, except the direction of the real power flow in reverse. रियल पावर जो है रिवर्स डायरेक्शन में फ्लो करता है सिंक्रोनस मशीन में, बाकी रिमेनिंग सारी चीजें जो है सेम होती है। सिंक्रोनस मोटर आर यूज्ड टू कन्वर्ट इलेक्ट्रिकल पावर टू मैकेनिकल पावर, एंड इट इज द डिजाइन फॉर द लार्जर पावर. It is uneconomical for the lower power. For a lower power application, we are using three phase induction motor and single phase induction motor in place of the synchronous motor. Synchronous motor are used where the power factor is the low, and this motor is also used for the improvement of the power factor. ठीक है? We are talking about the ऑपरेशन. अब देखिए ऑपरेशन जो है हम कल बताएंगे. अब जो है आप ऐसा करिए कि एक शॉर्ट नोट तैयार करिए आप लोग, ठीक है? नहीं तो सारी चीजें हवा में हो जाएंगी. अब मैं जो है